How's it going?
Good.
Chris, I've known you for a number of years, so it's great to see you. And really looking forward to talking to you today about our sustainability program and about sustainability in general and all of your expertise that we've come to appreciate over the years.
Oh, thanks, Dorian. I appreciate that.
You're talking about LCA's life cycle analysis. There's a lot of different ways that things are calculated around greenhouse gas, around CO2, but it seems that life cycle analysis is one of these things that are sort of a standard that we use to determine what happens during the life of a product, right? How does it go from when it was manufactured or created and all the way through cradle to cradle or cradle to grave kind of thing. So What are your thoughts about that?
Well, as we were saying, if you want to do good, you have to check the facts, and the only real way to know what's green and what isn't green is a life cycle analysis. As we said, everything has an impact, so what you do is you look at a cup or a bottle or whatever it is, or a car, and you work out which material causes least impact.
Yep.
And the way you do that is you add up all of the energy used to make the material and all of the water, all the pollution created. So the life cycle analysis tries to include most of the factors that you could find relevant.
Yeah.
And it's been developed over, I think the first ones were in the 1960s, so they've been around for decades, and they've been honed the whole time. They're done according to ASTM or ISO standards, and they're peer reviewed as well, so you can't pull a fast one and just make your product look good.
That's right. But at least with, when you look at the LCAs of these materials that are certified LCAs, that it actually has real numbers that are attached to it and can really give us at least a guidepost, right? At least we know how to navigate that and compare it, even if it's just a relative comparison to other materials or other processes, at least we have something.
Yeah, we need to do what's green according to the data instead of chasing an ideal.
Yeah.
People talk about containers, for example, and I see it online all the time. People are arguing that aluminium's fantastic because the recycling rate's high and look how much energy you save. But when you look at the life cycle analyses of containers, you end up finding that polyethylene and polypropylene and PET are the greenest solutions. Whereas glass and paper, they're much worse for the environment. They just burn a lot of fossil fuel to create the energy needed to heat them and so forth. So people have a misconception that because plastics are made from fossil fuel, they must be using more oil. And in fact, you can prove that the net effect of plastics is to reduce oil consumption because you need so much less energy to produce them, because they make cars lighter, they insulate our homes, they make food last longer. So the actual net effect, so you use about 4% of oil to make plastic, and you save more than that by using the plastic. And the other thing is, if you don't believe one LCA, that's why I went and found 26, which is, as far as I can tell, every one that was ever published on grocery bags, right? And they're from Singapore and America and Canada and Finland and Sweden and Germany, and every single one tells you that the plastic bag is the greenest. The polyethylene bag causes least harm, and you'd have to cut down millions more trees every year to replace it, right? So replacing with paper or cotton is absolutely scientifically proven to be worse for the environment. So we just need to be rational about it. And the thing is, in the old days, it was very expensive to do a life cycle analysis, but now there are databases where and it's all checked and verified, and it's been honed over the last 50 years so that people have good, solid data to start with, and they can make good conclusions based on that.
And it's a relative comparison, right? So that's how people usually use those numbers. So they'll say, well, the LCA of this material is this number, and the LCA of that material is higher. It's this number.
That's right. That's right. So life cycle analysis is the only way I know of to scientifically quantify the total impact of different materials and compare them so that you know what's greenest. So my opinion would be, as a scientist, what would be logical is to start with a material that has the least impact, proven by all of these studies, independent studies and peer-reviewed and checked and everything. So pick the material that starts with less impact and then just increase its recycling rate. Don't pick the worst material and then recycle that again and again and compound the mistake.